Welcome to Lesson 6 of iptables Mastery, the one where most silent firewall failures actually begin. Rules in a chain are read top to bottom, and the first one that matches wins. The kernel stops right there and never looks at the rest. That means an except placed above a drop, or a drop slipped in before your established rule, can quietly break everything. So today we're focused on ordering and the safety net beneath it all, the default policy. Here's the map for the next few minutes. 4 ideas that, once internalized, collapse most ordering bugs into a 30-second fix. First, top-down with first match wins, where a terminal verdict ends the journey. Second, the default policy as your safety net when nothing matches. Third, the difference between appending with -A and inserting with -I, which decides whether your rule fires last or first. And fourth, the cleanup tools, -D and -R, for when, inevitably, you need to fix what you just wrote. Let's start with the rule that governs everything else. The kernel reads your chain top to bottom and stops the moment it hits a terminal verdict. Look at the bad order on the left. The goal is to allow the office and block everyone else, but Rule 1 drops everything immediately, so the except for 10.0.5 never even gets evaluated. Swap them, and suddenly the office traffic matches first and passes, while everything else falls through to the drop. Same 2 rules. Opposite outcome. Order isn't style. It's the logic itself. Now let's trace a single packet through a real chain. An SSH connection arrives from 10.0.5.42. State new. The kernel checks Rule 1. Contract established? No, this is a new connection. Rule 2. Invalid? No. Rule 3. Loopback interface? No. Rule 4. Source in 10.0.5/24, TCP destination port 22. Match, verdict, accept. The kernel stops right there. Rule 5. The catch-all drop is never even read. 3 rules tested, 1 matched, 1 ignored. That's how every packet lives and dies. But what happens when no rule matches at all? The packet reaches the end of the chain, and the default policy takes over, the safety net beneath every decision. You have 2 choices. Accept means allow by default, convenient, forgiving, and the standard on most distros. But anything you forget to block is wide open. Drop means deny by default, the production standard, hardened and explicit. But get it wrong and you'll lock yourself out of your own server. Always add established and related first, and always test with a rollback timer. Once your chain has rules, you'll need to edit them. And iptables gives you exactly 4 verbs for the job. Append, with A, drops a rule at the bottom, the lowest priority slot, perfect for catch-alls. Insert, with I, places it at the top by default, which is exactly where you want your established and related rule. Delete, with D, removes by line number or by exact match. Use line numbers in your listing to find the right one. And replace, with R, swaps a rule in place, atomically, without shifting anything around it. Position-based or match-based. That's the whole mental model. So when you discover your rules are in the wrong order, and you will, you've got 2 paths. The surgical edit. List with line numbers, delete the offender, reinsert at the right slot. Clean for moving 1 or 2 rules. The nuclear option is what you reach for on bigger reshuffles. Arm a 2-minute rollback, flush the chain, and rewrite it top to bottom in the order you actually want. Counterintuitively, the nuclear path is often safer, because you're rebuilding deliberately instead of patching blind. Step back for a moment and ask why every serious firewall, iptables, nftables, PF, even Windows firewall, settled on the same linear top-down model. 3 reasons. Linear order is decidable. You read the chain top to bottom, and you know what happens. First match means the kernel exits early, which matters when you're pushing millions of packets per second. And an explicit default policy forces you to own your security stance. There's no implicit fallback to hide behind. Predictable beats clever every time. So here's your cheat sheet. Print it, tape it next to your terminal. 3 columns. On the left, the editing verbs. Append puts a rule at the end. Insert lets you place it at the top or any position. Delete and replace let you surgically fix mistakes. The middle column is how you inspect what's actually there. Always pair list with line numbers when you're about to edit. And on the right, the recommended order every hardened input chain tends to follow. Established traffic first, invalid dropped, loopback allowed, then your specific allows, optional logging, and finally the catch-all. Memorize that shape and you'll write correct chains on the first try. Now it's your turn. 3 drills designed to burn this lesson into muscle memory. In exercise 1, you'll deliberately create the shadow bug. Append drop, then append accept. Watch your SSH hang and confirm with packet counts that rule 2 never fires. In exercise 2, you fix it without flushing. Insert the accept at position 1 and verify the new order. And in exercise 3, you graduate. Build a proper chain and flip the default policy to drop, confirming SSH and outbound traffic both survive. Before you touch anything, schedule the 2-minute rollback. Always. Once you've drilled the basics, recognize the patterns that bite everyone. 5 classic ordering bugs, all syntactically valid, all silently wrong. Drop before accept shadows your rule. Established at the bottom kills your replies. Forgetting the default policy leaves everything open. Using -A when you meant -I lands your fix below an existing drop. And setting policy drop before adding established locks you out instantly. The fix, in nearly every case, is the same. Change the position with -I and put established at slot 1. So that's lesson 6. 4 principles to carry with you. The kernel reads top-down and stops at the first match. Your default policy is the safety net beneath everything. -A appends while -I inserts at the top. And specific rules always come before broad ones. Internalize those, and ordering bugs stop being mysteries. Next up, lesson 7. We leave filter behind and step into the NAT table, DNAT, SNAT, masquerade, and real port forwarding. See you there.